Okay, so let's suppose we have a system where the output of the system, y of t, is the integral from time 0 to t of the input. So we'll say x of tau, where tau is a dummy variable of integration. Okay? So conceptually what this system does is, if I can graph my input x of t, whatever it is, so this is x of t. Actually, we'll call this x of tau since we're doing a dummy variable of integration here. What this system does is it computes the area under x from time 0 up to some specified value of time t. Okay? So basically, the output of the system at any given time is the area between time 0 and time t. So at a later time, the output of this system is going to be the area under the input signal at this later time. We could call that t prime. So again, the area here, or the output, is the area from 0 to t. So is this system bounded input, bounded output stable? And the answer is, it turns out no. The way we can show this, to show that a system is not bounded input, bounded output stable, we just have to find one input that's bounded that gives an unbounded output. So suppose that the input is the unit step function. Okay, as we talked about before, this is a bounded function. So I can choose a equals 2, or I can choose a anything bigger than 1, and this is satisfied. So if I put this input into the system, the output's going to be the integral from 0 to t of this input. Okay, so y of t is going to be the integral from 0 to t of the unit step function, and as long as t is greater than 0, that's going to be 1. And you can work out this integral that y of t is now equal to t. Okay, and again, this is for the case where t is greater than 0, actually greater than or equal to 0. For the case where t is less than 0, then basically your output is going to be 0. Okay, so the question is this a bounded output? And the answer is no, because as t gets large, t gets large. And so I can't find a value b, some constant value b, so that for every value of t, y of t, which again is equal to t, is less than this value b. So this is a system that has a bounded input. Again, the bounded input is the unit step function and gives an unbounded output. The unbounded output would be t. To show what the system does to the unit step function graphically, this is the unit step function here. Again, it's computing the area under the unit step function from 0 to t. So this is that area, and you can see as t gets larger, this area gets larger.